Have you ever really stopped to think about what's going on inside the brain of your computer? I mean, how does a simple piece of silicon run literally everything from your operating system to your favorite game? Well, today we're going to learn its secret language. So here it is. At first glance, this microprocessor looks incredibly complex. And, it is. But at its heart, it's actually a pretty simple device. It's unbelievably fast, it's powerful, but here's the catch. It has no idea what to do on its own. It's kind of like a world-class orchestra sitting there with no music and no conductor, just waiting for a command.
And that's the big question, right? How does this little chip manage the trillions of calculations every single second that are needed to render graphics, connect you to the internet, and process every single click you make? The answer, it turns out, is surprisingly elegant.
The secret, it turns out, is its language. See, every single processor has a built-in dictionary of commands. It's not a human language, but a fundamental set of operations that are literally etched into its design.
This collection of commands is called the instruction set. The best way to think about it is as the processor's vocabulary. This is the complete list of every single action the chip knows how to do, from the most basic addition all the way to more complex logical operations.
So, if you look at a classic processor, like the 8086, you can see this vocabulary can get pretty big. But don't worry, we are not about to memorize a textbook today. We're just going to focus on the two most fundamental jobs any processor has, moving data around and doing the math. Okay, so before a processor can calculate anything or compare things or do anything useful at all, it has to get its data into the right place. This is job number one. It's the most basic, most common, and honestly the most important task it performs. Think of it as getting all your ingredients out on the counter before you even start cooking. And the undisputed star of this show is the MOV instruction. Now, its name is a little bit misleading. It doesn't actually move the data in the sense of cutting and pasting. It copies it. It makes a perfect clone of a piece of data from a source and then places that copy in a new destination, leaving the original completely untouched.
The way you write it is just beautiful in its simplicity. MOV, then where you want it to go, the destination, and then where it's coming from, the source. So MOV AL BL just tells the processor, hey, copy the value from register BL and stick it into register AL. It's basically the chip's version of Control-C, Control-V.
Now, even this super simple command has some interesting rules. First, and this is a big one, you can't just move data from one spot in main memory to another. It has to take a trip through a processor register first, kind of like a mandatory weigh station on a highway. Second, the containers have to be the same size. You can't pour a 16-bit value into an 8-bit cup. And finally, some special registers are protected. They're off-limits as a destination.
Copying is absolutely essential, but sometimes you need to do something a little more advanced. What if you need to look up a value in a table? Like converting a number code into a letter you can actually see on the screen.
For that, you've got commands like xlat, which, you guessed it, stands for translate. And this is a brilliant example of more complex data movement. Here's how it works. You set up a lookup table in memory. You put an index number, let's say the number 5, into a special register called AL, and then you just run xlat. The processor automatically zips over to the 5th entry in your table, grabs that value, and copies it right back into the AL register for you. It's an incredibly powerful shortcut for data conversion.
Okay, so we're pros at moving data around efficiently. What's next? Well, now we have to actually do something with it. And that brings us to the arithmetic core of the processor.
This is basically the processor's built-in calculator. It's got simple, direct commands for all the basic math you'd expect. Add, subtract, multiply, and divide. And it even has these handy shortcuts like INC to just add 1, DEC to subtract 1, and NEG to flip a number's sign from positive to negative or vice versa.
Let's look a little closer at addition, because it's pretty neat. You've got the standard add command, which is exactly what it sounds like. But then you have ADC, which means add with carry. This is the secret sauce for working with really big numbers. If you add two numbers and the result is too big to fit, the processor flips on a little light called the carry flag. It's just like carrying the 1 in grade school math. The ADC command then does the next addition and remembers to include that carried over 1 in the new total.
And subtraction works in a very similar way. Subtract is your everyday, straightforward subtraction. But SBB, subtract with borrow, is its partner for those trickier problems. If you need to subtract a larger number from a smaller one, you have to borrow from the next column over, right? Well, the SBB instruction automatically handles that borrowing for you using that exact same carry flag.
Multiplication is where things get really cool. The processor just knows that when you multiply two numbers, the result might get a whole lot bigger. So as you can see here, if you use the MUL instruction to multiply two small 8-bit numbers, it's smart enough to automatically store the result in a larger 16-bit register. And if you multiply two 16-bit numbers, it uses two registers together to hold the potentially massive 32-bit result. It's literally planning ahead for the answer to be big.
So we've got moving and we've got math. I know it might seem basic, but these two categories of instructions, they're the absolute foundation that everything else is built on. You're looking at the atoms of the digital universe.
Just think about that for a second. Every single piece of software you have ever used, no matter how slick or complex it seems, is ultimately just broken down into a massive, lightning-fast sequence of these incredibly simple commands: move this data, add that number, copy this thing over there.
So the real takeaway here is this: the magic of modern computing isn't in some single super brilliant command. The magic is in the processor's ability to execute billions of these primitive, simple data movements and arithmetic calculations every single second, layering them on top of each other to create the incredibly rich digital world we all live in.
It's a pretty powerful thought, isn't it? The entire digital world, all of it, written in this simple, basic vocabulary. So now that you know the language, if you could talk directly to the processor, what's the first thing you'd tell it to do?